Before we start looking at these examples through the series of videos, and there's going to be several videos in this collection, I want to answer a question of why. If you open up any beginner programming textbook, whether that programming may be Python, C Sharp, Java, they usually begin to introduce basic geometric shapes very early on in the topics. And that does two things. One, it tends to cause students a little bit of angst. The students then believe that they need to have a very high level of mathematics to do any kind of application development. And fundamentally, that's not true. Most of app development will involve basic arithmetic, counting, subtracting, dividing, multiplication, things like that. Then the question is, why do most entry level textbooks courses immediately jump into geometric shapes? The answer to that really is it's quite easy. Not that geometry is easy, but geometric shapes allow the book, the professor, the instructor to explain some of the other concepts associated with programming logic. For example, it allows us to explain what an integer is, what a float or a double is. It allows us to concern ourselves with power of operations. We can do things called typecasting, where maybe we input a string, but we have to first then convert it to a integer, or we have to take the value that we acquire and maybe that's a float or a double and turn that into a string so we can print it. So let me show you some of the four basic geometric shapes I'm going to be using in this series of videos. If we look here, again, none of this is high level math, but if we take, for example, the square and the rectangle, basically a square is a rectangle. It's a special type of rectangle that all four sides are equal. And we can see with these geometric shapes that we can find out the area, that's all the stuff inside the angle, the perimeter, what goes around it. It's basically the same. And we can then demonstrate integers, right? We can make the assumption that all the sides are an integer or a whole number. We can then expand it to say, okay, the sides are floats or doubles, meaning that they have some kind of fraction. Maybe the side is 2.5 instead of 2. So rectangles, squares, they afford us to do some demonstrations on integers. Then we get into circles and triangles. Well, what do circles and triangles allow us to do in programming logic as we're learning how to code? Well, first of all, circles and triangles by their very nature are going to be a float or a double, meaning that they're going to have some kind of fraction associated with them. We can definitely look at a circle and finding the finding the area and the circumference requires the use of pi. Pi is an irrational number, meaning that there's decimal points after the 3. So we know when we find the area or circumference of a circle, we're going to be dealing with a float or a double. Somewhat same with the triangle, because if you notice on the triangle, the area of a triangle is 1/2 base times height. So there's a good chance, just because there's that 1/2 there, that this could be a double or float. Doesn't always have to be, not like a circle, you're pretty much guaranteed. But a triangle, good chance that you're going to be using a float or a double. So I want to spend a couple minutes very early on in this series of videos to explain why we use basic geometric shapes. It's not an indication that app development programming requires a high level of math. But what it does is they're perfect examples to explain different types of variables. And as we go through these videos and these examples, keep these in mind, keep these basic geometric shapes in mind, and I will use them in my examples.